So, welcome back from the lunch break. I hope everybody's doing well so far. We will start right now with the second part of this day. And we will hear 2 more talks until our next coffee break. So, then you will receive coffee like expected next behind the door. So, the next talk will be held by someone who's coming from Antwerpen. He is doing a lot of open source community stuff. He is well known for a lot of talks and conferences, and he's also responsible for major open source IT infrastructure in a lot of companies. And today he will talk about Schroedingers backup. So we will see if Tosh will present us some nice cat pictures or not. So please welcome Tosh.
I'm from Belgium. I'm self-employed, a consultant. I have done some open source stuff. I do some conferences also. I do the config management camp after FOSDEM. We have load days also in Belgium. I've been involved with some of the projects. I typically do more the hardware and the lower software stuff, so the operation stuff. I don't do that much development anymore. But that's, well, if you want to know more, you can ask me. So I'll give you a short introduction. I'll talk about some of the techniques. I'm not that heavy a user of BAROS. We have some customers who use it. I'm going to talk more abstract and how to check things. And first, I called my presentation Schroedinger's backup. So we first have to introduce who Erwin Schrödinger is. I presume everybody knows this already, but he is the father of quantum physics. He won the Nobel Prize in 1933 for quantum physics. That's how he looked. And that equation is what is on his gravestone. So it was so important for him that he put it on his grave. Well, his wife put it for him on his gravestone. So yes, he was very well known for quantum physics. Now, he also, in his spare time, devised a certain idea, as in the Schrödinger's cat. So he had this problem that in quantum physics, you could be at 2 places at the same time. You had a lot of these ideas which are unrealistic and actually quite improbable for a normal human being to understand. I mean, it is very difficult to explain that you could have molecules in you which could transfer to Mars within a next second. Now, of course, the likelihood of that happening is very small. You would have to wait the lifespan of the universe for such a thing to happen. But mathematically, it is possible. So he devised this little bit more easier thing to understand. He said that if we put a cat in a box and we add some radioactive poison, which we do not know has broken or hasn't broken, then the cat would be at the same time dead and alive, because we wouldn't know what is happening in the box. Now, when we make backups, we typically do backups. We get a verification, BARIOS or rsync or whatever tool you're using will say the backup is done. But how many people actually go and check the contents of that backup? And that is why I named my presentation as such, because most people have backups, but we do not know what the state of this backup is. Can this backup be restored or not? As Daniel said this morning, I have a small data center of my own, 9 servers in it. Beginning of July, in a span of 2 weeks, 7 of them crashed within 2 weeks span. I was able to rebuild and restore everything, even though I hadn't tested everything necessarily in that detail. But I was lucky to be able to do this. And that is why I wanted to present this, to give more understanding that doing a backup is important, but being able to check this backup and to be able to make sure that you can restore this backup in whichever way that works for you is also important. Now, for this backup, we typically need to understand what your system is built of. A typical machine, be it bare metal, be it a virtual machine, be it a container, is typically made out of four types of systems. I mean, four types of integrations. The operating system, be it Linux, Unix, or Windows, an application, the configuration for this application, and the actual data. Typically, people will make a backup of the data. And that will work, but if you can't restore your configuration, then you need to think at the point that you're in this state of restore and maybe even in panic, with your boss hanging over you, asking you, when will it be ready? If you can automate these things, then again, you are a step further because you press a button and magic happens. And if you have tested this magic, then you can sit down peacefully while your boss is also sitting down peacefully. And maybe even have a conversation on how you should do it next time even better. But again, we need to look at these 4 points to understand how to do a full restore. I am again presuming that you have a complete burnout of your data center, so we need to be able to build everything from scratch again. So some of the techniques, you have snapshotting. You can do that of an operating system. You can do that of a file system. You have dumping, which is mostly for databases. So most of the major databases support some kind of dumping. You will have copying, which is basically some copy or rsync type of application. And then you have some of the newer applications that actually have built-in features. We saw this morning that Elasticsearch has one of these type of backup tools, which can actually also back up all the type of data. So you don't need to worry about configuration, about data, about anything else. It creates a single package with all your data configuration and so on in it. Snapshotting, if it's machine-based, if you want to do it metal, you can use a tool like Rear. Gratien will be talking later more about that. You can use Clonezilla if you really want to have a different type of cloning. There are people who use Puppet or Ansible. In my case, I use Ansible for all of these things. But again, this depends on your setup, whichever tool works for you. If you want to be sure, you might even want to use 2 or 3 of these tools to combine for on-site and off-site backup. For virtual machines, you typically have the snapshotting. So KVM has snapshot create as, which will create a snapshot of your VM. And then if you have applications that don't segregate data configuration that well, it might be even easier for you to do this and to create a snapshot of that than to have to recreate or rebuild everything if you don't know how it is built up. VMware has the same. For disk-based, you have LVM snapshots, which basically take a snapshot of the file system. So you will typically have all the data on that file system. There are a lot of other ones. So most of the major file systems, even Windows, Unixes, all have this features built in, which means you can take a snapshot and you can actually have the image as it was on that machine at that point. Now, how do you test snapshots? And that is the more complicated part. If you want, you can test them outside of the business hours. This is easy for VMs. You can actually shut down the original VM, take the snapshot, boot it up, and see if you can get to your data from your clients. You can, if you have a very rich employer, buy extra metal just for this. You can create new virtualized environments for testing recovery, which is something I mostly now do for customers if they have applications which are a combination of data and configuration or are based in such a way that we cannot separate data and application that well. Typically, larger companies have these drills where they will have the recovery day, where they will test it once every 3 months, once every 6 months, once every year, where they will see, can we actually restore now and get back all our infrastructure? Each one of these techniques has their own disadvantage and advantages. Based on your infrastructure, you need to decide what is possible and what isn't possible. Configuration. So typically, today, configuration should be templated and automated. So installing an application and manually going and writing the configuration file shouldn't be done anymore. We see this still a lot, well, I still see this a lot with companies that they actually try to manually configure each service. If you're doing that, there is a very good conference after FOSDEM, Config Management Camp, which describes how to do this. No, but seriously, if you're still building your configuration manually, you need to think about how you automate that. Not only from a perspective of restoring, but also from a perspective of reproducibility. You want to have always the same configuration. You want to be able to predict what will happen, and with templating, you can actually do that. So there are some tools, Ansible, Puppet, Chef, which can actually help you to do that. Depending again on what you want. And they can actually build a configuration for you and deploy it on that specific machine. So an example, most of my examples are Ansible, but this is as applicable for Puppet, Chef, Salt, or whatever your favorite configuration management tool is. In this case, it's Piwik. It's an open source Google Analytics tool. So in this case, we get the latest version of Piwik from the internet. We deploy it there, and we unzip it, and then we copy the configuration file. So in this simple 3 steps, we actually are configuring, well, we are deploying our application and configuring our application. Now the configuration would look something like this. So this is the standard configuration, and you template it. Given that it's an Ansible example, it's with Jinja 2. If you would be using Puppet or Chef, it's a Ruby syntax. If you're using Salt, it's also Jinja 2. So it depends on your tool. But it basically means that you get to put in variables, and these variables come from your central database, and they get filled in once they are deployed on that specific machine. This means that you have this data already stored somewhere externally, and you can back up that to a separate instance, but it means that your deployment is not the only place you have this logic. For another application, I've just generated, because a generic version. We have some customers who have Windows applications, so you need to be able to install them also. Again, Ansible can do that. You can get it, install it. You can even put all the registry keys right, because typically they don't work with configuration files. They work in a different way. So you can even get your registry set up properly and hold your application running. So regardless whether you're Linux, Unix, or Windows, the tool applies for all of them. And that's the same for all the other open source configuration tools. All of them support the major platforms. So that's from a perspective of the application itself. If you have a normal application, then you will have your application, your configuration, and your data separated. I'm giving here a few examples of data from Postgres MySQL. So this one is a Postgres, so you basically just dump your data of your specific file, of your specific database to a file. The diffing is what we use to actually get the extract to know what has changed. That will be used in the automation tools for testing purpose. So we can actually see, let's say if it is a simple invoicing application, you know that you will always get new sequences of numbers. So there is some logic you need to apply in this, and you need to know something of your application also to be able to do this. And then we compress it because it saves us a little bit on storage. Similarly, We do the same for the MySQL and friends. So MariaDB, Percona are basically all the same. We do the dump, we again do the diff, and we compress it and store it. If you have a Microsoft SQL Server, you can do exactly the same. You can script this and get it automatically backed up to a specific place. That can be a shared storage, that can be a local space which you write away, that can be even somewhere where Barrios puts that on a tape or whatever you want to do with that data. Some of the other applications I know are mostly Git-based applications. So if you run your own Git installation, then you can use Gog's backup or Git or GitLab, and will actually create a zip file with all the repository data, the database application, and all its configuration in that one zip file. Which means that if you run now Gog's restore, it will actually restore everything to that point of the backup, including all data, all configuration, all databases. And there will be other applications that can do this also. Most of the newer applications typically want to create a backup solution that is more compact, and that gives the user the ability to back up without having to understand each of the subcomponents of an application. If you're using files, yeah, you can do rsync. You can rsync it. There are other tools which are also quite popular, but we still use rsync because it's quite easy and convenient. And it gives us the ability to send this over the internet in a secure fashion because it uses SSH by default. We don't need to worry about encryption or setting up TLS. Everything is done out of the box. Now, we have created all these backups, and we would like to know that the backup is actually done properly. And that is the part which is more complicated. So there is no one solution for this. You need to know your application. You need to know what you're doing, which makes it much more complicated. The thing that we have now been doing a lot for customers is creating virtual environments where the customer can go and test it. So you create the server application, the client application, and they can actually go and test that data from yesterday or from a week ago and actually even see what has changed. We are trying to automate that, to create that in a pipeline where the automation tool would actually know what data has changed and how it has changed. For that, you need to understand the data itself, which is why there is no one solution for this. If you are having, like I said, an invoicing application, it's easy. You always know that your sequence numbers will go up. If you have a price calculation, then, well, you don't know what the price yesterday was or how you can verify that. If you're backing up GPS locations, it becomes even more complicated because if tomorrow this GPS module goes out of country, how can you verify that? So knowing the application is very important. Creating this type of isolated environments gives the user the ability to log in and to actually verify manually that. It's not 100%, but it works and it gives them a feeling of what it would be if we would restore it without having to invest too much into new metal or new setups. So for the invoicing program, what we typically do is we select all the sequences and we check whether there are any sequences missing. So we know that for most of these legal requirements, the numbering has to be sequential. So it has to go from 1 to, let's say, 1,000. And if there's any number missing, then there's something gone wrong. These are, of course, simple examples. Like I said, you need to know your application to understand what the thing is you're trying to achieve and what you want to do. For a MariaDB cluster, we typically just do a restore to a different database name, and then we can actually compare the two databases running selects or whatever the internal data is. You can actually see if the products are still there. You can actually see if the data is there. Again, an understanding of the data is quite important to be able to do this, which makes it a little bit more complicated. With shared files, we typically do checksum verifications, which is good if you have, let's say, like letters. Typically, people write a letter in a Word document. You can do checksumming. If they don't edit the letter and only create new ones, we can always keep this checksum and validate against that. We could do content checking. So we have a, well, I have a customer which does everything in Excel. They actually have a specific logic in Excel. So there is a Python module that we call, which actually verifies that the data was set properly based on the input that the customer gave, and checks every day whether the backup was done properly. If it's not done properly, he gets an email, and then he can check that. Timestamp verification is another option if you have no other way to verify. And yeah, human eyes, typically telling an end user to go and verify data is maybe the first 1 or 2 days he will do that, and after that he will stop doing it. He will presume that it's done automatically because he got a green sign in his monitoring tool that backup was done, but you don't know the content. And also sometimes users don't know the content that they need to verify. Typically, if we ask initially when we are checking backups, we go and ask customers, what did you do yesterday evening last, so I can verify that the last entry, whatever you did, was what is in the backup. Most of them will look at you as if you're asking some alien question, because they don't remember what the last thing they did was yesterday, which makes it also difficult for us to verify that this data is done actually quite correctly. And yes, do not trust your end user. And that goes both from an end user perspective. I come from operations. I don't trust the developers also. And I see people laughing, but I've had this happen. That's why I wanted to give the presentation. We have an external company which supplies a bookkeeping software. The end user in perspective asked them officially by mail, how do we need to back this up? They gave a specific method of backing up. We followed their instructions and wrote our script based on that. Luckily, we were using also REAR there as a disaster recovery. Their backup could not be restored. When we called them and told them, here's the backup, please do it, they were not able to do that. So the customer lost 1 day of work because the DRP only runs once a day, not every hour. Most of these data dumps we do every hour, so you can lose up to 59 minutes. But if we hadn't done the DRP exercise, the customer would have lost much more. So trusting end users and developers is sometimes very risky because typically the operations guys get blamed, which is one of the reasons why I also showed the VM snapshotting. It's very cumbersome, and you're not going to keep 10 days of backup of that, but it gives you the ability to go to yesterday's state and to get something at least from your backup solution. And I know Barrios can do many of these things also, but it will typically back up data or applications. If you need really the complete set, there are only very limited tools that can actually do that and guarantee the state that it was in before and guarantee consistency. Yeah, automate your backup solution. I don't think I need to tell you that, but also try to automate your restore process. Try to automate the restoring of data, try to test that, and to verify that those restoring processes actually work. Like I said, there's no one solution because you need to know the content of your data, and that makes it a little bit more complicated to give one solution for that. Data is different. If it's database dumps, it's a little bit easier. Even then, we need to know the content of the data, which, given that we are not the application developers, we don't always know all these details. Yeah, I don't know.
So there's time left.
Yeah,
so
there's time left.
you're finished. Okay, thanks. Are there any questions for Torst? Yes.
Hey, do you've got an idea how to test such kind of multi-server environments in a special test environment? Let's say if you got a database server, an application server, and let's say a front office PC or whatever. Each of them has got a different IP address in the testing environment and also a different server key or certificate. Is there any way to do this automatically, or?
So what I've now done, and we have this now for one customer only for the moment, where we are testing this, is exactly the setup like you described. You have an end user client, you have an application server and a database server, and we have virtualized that in an isolated instance where the customer can log in as if he's on a client and actually see all that data. And because we are doing a VM snapshot, we can actually do the VM snapshot one time to create this instance, and then dump the database every hour, and dump the application sessions or any statefulness that you need also every hour. So you can actually go back an hour or even 2 hours or 3 hours, because you can, that part of the interface is not yet working properly, but I would like to have it that you could actually say, I want to go to the state of 2 hours ago and verify that. For the moment, we can only show one state at a time. We don't have a selector yet, but that's the instance that I'm trying to build so that you can actually have this verification. It's more or less automatic except the client verification. The problem with the client verification is you need to know what data you need to verify. If it's, let's say, like an application server and you want to know what I've tried to do is, if it's a web server, you typically can put the version at the bottom, and then you can have some curl script which actually detects the version or detects whether certain entries are there. But then again, you need to know the data, you need to know the application. For the moment, we are allowing end users to log in and to verify that, okay, I need to have my quarterly reporting. Was my quarterly reporting backed up or not?
Okay, I'm just worrying about the initial setup of the test environment, because we've got host keys different and stuff like that. Just to get it working initially on the test environment. You
just take a snapshot and you create an isolated network. And because it's isolated in its instance, it can actually have the same IP range, same host name, same everything.
Okay.
So we basically copy the existing infrastructure to a virtual infrastructure which is completely isolated and segregated from the production network. But because it looks exactly the same and because it has no connectivity with the other ones, it doesn't conflict in IP ranges or host names. And it allows you to copy the data also at any time. Because if you change IPs, you might have to change the configuration. Then you need, again, an external tool to do that. Given that it's a complete replica, it's basically the same.
But how do you restore the information and the data into the isolated environment? I mean, it's the same IP address, but without any access from the outside. So how do you get your backup system, restore your data within this virtual environment?
You do that through the hypervisor. So the hypervisor, I can only tell you from a KVM point of view. In KVM, you can create a libvirt network and isolate it from the outside network, which means that the hypervisor still can copy data into it, but the application server sees only that database server in its isolated network.
Okay.
So that's how you create it. It's a little bit complicated. If you want, I can draw it out afterwards. If you see it visually, you'll understand it better, I think. Thanks. Any other questions?
Yeah.
Just one small question about the GitLab rack stuff. What did you mean with these kind of tools to back up?
You mean with these ones?
Yeah, indeed.
So these are tools that the application provides, which is basically, so I know the ones of GOGS by heart. They're basically, they copy the repository in a zip file. They add the data dump of the Postgres or the MySQL that you're using in, they don't use the typical MySQL or Postgres dump. They use XML descriptors. So they do data definition descriptors, and then the change data they keep so that they can actually compress it a little bit more than typically what you do with a data dump. And that is one zip file that gets created. Even your gogsconf file gets put into that. So if you install gogs, which is a Go application, so it's typically only one binary, you can actually just take the binary, do a restore, and it will put everything in the right place again. For GitLab, that's nearly the same thing. The only difference there is you need to have Omnibus before you can do the restore. That's all.
Okay. There are still questions left. So then I have one. So what do you use to automate the testing? Which tool are you using for automate the tests?
I'm using MQTT. So basically, MQTT sends a message on the bus, and then whoever is the receiver receives it and executes a specific command based on the MQTT message that was sent. Okay. It's typically you would use Jenkins or BuildBot. I use this because it's much smaller. It allows me to have it over multiple data centers. It allows me also to connect to my client's data center. With Jenkins, you need to have SSH then to secure all of that. MQTT has TLS built in, so it's a little bit easier.
Okay, sounds good. Questions left? Okay, then thanks, Tosh, for this talk. So